In this video, we're going to focus on long answer questions, those related to bonding and structure, and particularly comparing the properties related to that. So here's a typical question on bonding and structure that is worth 8 marks. It can seem a bit daunting at first, so it's important to take a moment just to work out what the question's asking and what you need to focus on in the answer. So don't always assume that because there's a table, you need to talk about everything. Sometimes the question might only ask you to compare, for example, 2 out of the 3 substances, like magnesium and oxygen, or to just discuss one property. But in this question, it is talking about all 3 substances, and it is talking about both properties because it just says differences in physical properties. And it's also very clear that you need to discuss structure and bonding for each of those substances. So actually, although 8 marks can seem daunting at first, when we consider that there are 3 substances here and that there are 2 different properties, melting point and electrical conductivity, and that we need to talk about bonding and structure, you can see that actually it's quite easy to get a lot of marks in this question. What we shouldn't do, however, is assume that if we write 8 things, there are 8 marks, because this question is also likely to be what is known as a level of response question. So this means that there will be some marks available for the quality of your written answer. Looking on the right-hand side, you can see that these questions normally only ever give you 2 marks out of however many it is, and it's for the structure and a sustained line of reasoning. So what we really want is clearly linked ideas. So we don't want to go from one thing to another and be jumping around all over the place. And we also want a logical structure, which is kind of the same thing. We want one point in your answer to follow the previous point and for them to be linked together. So this sort of quality of written communication or level of response, it shouldn't be your main focus. But what it should make you do is maybe just consider and plan your answer, because then you're much more likely to score high marks even without this idea of like how structured it is, because you're more likely to mention everything that you're meant to say rather than just launching straight in and kind of, writing everything you can think of. So there are 2 ways you could approach a question like this. Firstly, you could focus on the properties separately. So you could go, right, I'm going to talk about melting point first. I'm going to talk about magnesium, oxygen, then magnesium oxide. Then I'm going to talk about electrical conductivity. However, the other way that you could do it is you could take each substance separately. So you're going to say, I'm going to talk about magnesium first. I'm going to explain the melting point and I'm going to explain the conductivity. Then I'll talk about oxygen and explain why that has a low melting point and no electrical conductivity. So this second idea is much more reliable, and that is because you're much more clearly going to link the structure and bonding to the properties. So that's how we're going to take it. So we're going to take each substance one at a time. We're going to identify and describe the bonding and structure. Good job there's no handwriting marks in this. And then we're going to link it to each property, in turn, melting point and conductivity. This is much more reliable. You're much less likely to have to repeat yourself as well, because if you talk about just melting point, you're going to have to talk about the bonding and structure, and then you have to bring the bonding and structure up again when you talk about electrical conductivity. So this is much more efficient way of doing it. Treat it like 3 questions almost. So let's start with magnesium. First of all, we need to identify the bonding, which is metallic, and the structure, which is a giant lattice structure, and that's because all metallic substances are giant lattices. Okay, when we talk about the melting points for lattice structures, we have to talk about the bonds that are broken, and the best way to do this is to describe the electrostatic attraction. So basically we're going to describe what we mean by metallic bonding. So there are strong electrostatic forces of attraction between, and this is how all of your bonding explanations or descriptions should start, and for a metal it is between the cations, the metal cations, and the delocalized electrons. So we've identified what the attractions are, but we've also used the word strong in there. So we're already on our way to explaining the high melting point, because we've said that the forces of attraction are strong. To make the link between attraction and melting point, you need to talk about energy, because that is our link to temperature. So therefore these attractions require a large amount of energy to overcome or to break the bonds. Therefore, Mg has a high melting point. Don't forget to do that stating the obvious thing, okay, so that otherwise you're not linking your answer. If you simply leave it at, oh, lots of energy to overcome, you haven't said which property you're actually explaining, so that is the stating the obvious point. So that link between forces of attraction, energy, melting point is a really, really useful thing to use in all sorts of long answer questions. Now we look at conductivity. We don't need to repeat ourselves. We've already explained what metallic bonding is. So now we just identify what part of that is responsible for the conductivity. Conductivity is about charged particles that are able to move. So we can say that Mg conducts as a solid or as a liquid, which is what molten means, and it is because the delocalized electrons are free to move. That is what we mean by delocalized. They can move through the structure, they can carry charge. Don't just say they can carry charge. It really is about the movement, the free movement through the structure that results in conductivity. Okay, so let's move on to the next substance in the question, oxygen. Bonding in oxygen is covalent, but it's more important not just to identify its bonding, but its structure. And that is because covalent substances can be molecular or giant. So we need to say that oxygen is a covalent molecule, or that it has a simple covalent molecular substance structure. I don't like using the word simple covalent particularly, because I really want to get the word molecule in there. And simple can be a bit misleading because very complicated things can still have a molecular structure. What we mean is it's not giant. And because it's not a giant structure, it's not a lattice like diamond or graphite, we definitely don't want to talk any more about covalent bonding at all, because it's completely irrelevant. Strength of covalent bonds is not what we're talking about here. We don't break covalent bonds when oxygen turns into a liquid or a gas. So what we want to say instead is that oxygen only has weak intermolecular forces. Now you could say between molecules, but the word intermolecular already means between molecules, so we can say only has weak intermolecular forces which require very little energy to break, and therefore it has a low, or has a very low, because if we're comparing the other ones, it really is extremely low in terms of its melting point. Now we want to talk about conductivity, And again, we think about what it is that makes something conduct. It's charged particles, either electrons or ions, that are somehow free to move. So oxygen doesn't have delocalized electrons and it doesn't have ions. So that is our explanation for conductivity or lack of. So it does not conduct electricity as it has no delocalized electrons, but don't leave it there because some other substances don't have delocalized electrons either, like the one we're about to talk about, or free moving ions. It doesn't have any ions at all. Okay, now let's look at the last substance, and that will be magnesium oxide. So again, we're going to identify the bonding, which is ionic, and therefore, because it's ionic, it is a giant structure. So MgO has a giant ionic structure, or you can say is a giant ionic lattice. Because it's a lattice, we're going to use the same kind of explanation for melting point that we did for magnesium. We're going to identify what those attractions are, those forces of attractions within the structure. So we're going to describe ionic bonding. Notice that we didn't do that for oxygen because there was no point describing the covalent bonding because it wasn't relevant to the melting point. So again, we have a high melting point, very high, so we're going to talk about strong. So it has strong electrostatic forces of attraction. This time it's ionic, so the attractions are between oppositely charged ions. And we can say, just like we did before, that these require a large amount of energy to overcome or to break the bonds. So the melting point is very high. We're going to say very, because actually it's the highest melting point there is. We could even say that these electrostatic attractions are much stronger than the metallic bonds in magnesium. Finally, though, we need to also talk about conductivity. So there is no delocalized electrons in any state unless something is a metal or graphite. So we don't want to talk about electrons, we want to talk about ions because it's an ionic substance. So we can say it conducts when molten, because ions can move and carry the charge. And we said it does not conduct as a solid because the ions are fixed in place. So we've done a nice clear comparison because we need to explain both points, not just one or the other, like ions moving when molten or not moving when solid. Okay, just to finish this off, it's worth looking at a few things like things we should avoid in this question. Students often lose marks, or for example, where they might leave things out. So one thing we should definitely avoid is the word atom, because none of these actually contain atoms as particles. They are either ions or they are molecules. So magnesium, cations surrounded by electrons, oxygen, O2 molecules, magnesium oxide, ions held within a lattice. There are no atoms anywhere. So if you use the word atoms, you can often lose that mark. Where else we lose it is by not talking about structure. So don't talk about the strength of covalent bonds. is not relevant. The only thing we should talk about strength of covalent bonds is if we were talking about those very few examples of giant covalent lattices, diamond, graphite, silicon dioxide. It's not relevant to melting point for anything else. We should also not be talking about intermolecular forces when describing our metals or our ionic compounds, or indeed if we were doing a question where we were describing giant covalent. So again, massive no-no. It's really easy. We love the words intermolecular force. We learn them at A level. It makes us sound clever. We want to put them in, but unfortunately, even if you correctly talk about all the other electrostatic attractions, if you start talking about intermolecular forces, you are instantly going to minus at least 1 mark. So don't talk about that when you're talking about a giant structure. Another way that we can lose marks, so when we've got a lot to write, and I was finding that I was sort of, running out of space there. And what we might want to do is use symbols or formulae to represent these substances instead of writing magnesium oxide every time. So this is not a problem that should affect your level of response marks, so long as you do it correctly. So it's okay to talk about Mg. It is not okay to talk about O. I need to be describing it as O2, for example. Now, MgO is an easy formula for magnesium oxide. So again, I did use that when I was talking about it rather than having to write out magnesium oxide, which is a bit tiresome. And so that is fine, but just be really try and keep it at the front of your mind that not all of those formulae are going to be like that. Okay, so if a question says magnesium chloride, don't just write MgCl because that's not the formula, it's MgCl2. So you need to be switched on and make sure you have the right formula if you're going to do that. If there's any doubt, write the name instead because you've got that in the table anyway. You may be given the formula, so that's fine. A couple of other mistakes that we could make. So while we're at that, don't use or try to avoid it or they unless it's very clear. So if you go back over my example writing, I've only used it or they when it's directly followed on from a sentence that has only had one thing in it. So for example, I've mentioned the strength of electrostatic attractions and then I have said that they require a loss of energy to overcome. But every time you write it or they, as you write it, check back on what you just wrote to make sure it's clear what it or they refers to. And finally, remember that not only electrons conduct or carry charge. So it's really easy to get sucked into the delocalized electron explanation when you are talking about an ionic compound, but remember ionic compounds never have delocalized electrons. They just have ions. Otherwise there wouldn't be any difference in conductivity between solid and liquid state. And that's it. Get some practice in, do some practice questions, and you will find these sorts of long answers are quite repetitive and they're easy to score highly on just so long as you do a bit of practice.